Let's analyze a spring mass system described by the differential equation U double prime plus U prime plus 5/4 U equals 3 cosine t, with initial conditions U of 0 equals 2 and U prime of 0 equals 3. We'll find the solution and analyze its behavior. We have a second-order linear differential equation representing a damped spring mass system with external forcing. Our goal is to solve this initial value problem completely. First, we solve the homogeneous equation by finding the characteristic equation and its roots. The characteristic equation r squared plus r plus 5/4 equals 0 has complex roots. -1/2 plus or minus I, indicating undamped oscillatory behavior. Thus, the general solution of the homogeneous equation involves exponentially decaying oscillations. For the particular solution, we assume a form involving both cosine and sine terms due to the trigonometric forcing function. Let's compute the first and second derivatives of our assumed particular solution. Now we substitute the particular solution and its derivatives into the original differential equation. Matching coefficients of cosine and sine terms gives us a system of equations for A and B. Solving this system, we find the values of A and B for our particular solution. The general solution is the sum of the homogeneous and particular solutions. Now we apply the initial conditions to determine the constants C1 and C2. We solve the system of equations from the initial conditions to find C1 and C2. This gives us the complete solution to the initial value problem. The solution consists of two parts: transient terms that decay exponentially, and steady-state terms that persist indefinitely. For large time values, the transient solution becomes negligible, and the system approaches the steady-state oscillation. Physically, this means the initial conditions affect the short-term behavior, but the long-term behavior is determined solely by the external forcing. We have successfully solved the spring mass system and analyzed its short-term and long-term behavior.